Okay, this is for number 70. I'm actually going to use the drawing down here, but I'm going to ignore these measurements because obviously it's different because we're doing number 70. Let's describe what's going on here. They say that it's a square base and that the sides are all 10.9. So this is 10.9 and this is 10.9. And it says the sides rise at an angle of 48 degrees. So that means this angle here, if you were to kind of draw in a line right there, that angle right there is 48 degrees. Well, we can make a little right triangle here with the height, and technically what's the apothem of that shape? And this should be a 9. And they want us to find the lateral area of the pyramid. Okay, that's not too bad. Remember that lateral area of a pyramid equals 1/2 perimeter times slant height. So this isn't going to be too hard to find because we know the perimeter really easily. It's just 10.9 times 4. So that's 43.6. And now we just need the slant height. Well, the slant height's a little bit trickier. That's this number. And what we have here is we have half of 10.9, right? Because if this goes right to the center, and this whole distance is 10.9, and this is 10.9, then this is half of 10.9. So 10.9 divided by 2 is 5.45. So let me just write that in here. All right. So here's what we got. Let's look at our triangle here. We have an angle and a side adjacent to that angle, and we want the side, the hypotenuse of that triangle. Okay, well, what trig function uses adjacent and hypotenuse? Well, it's cosine. So we're going to say the cosine of 48 degrees equals the adjacent, 5.45, over the hypotenuse, which in this situation is the slant height, the number that I want. So let's just switch these two. That's something that we learned we could do, so we would just write L equals 5.45 over cosine 48. So there's my slant height. So I can plug that in up here. And there we go. Let's see now. The rest is all in the calculator pretty much. So 43.6 times 1/2 is 21.8. And so I'll just simplify it for you real quick. Okay, we get 21.48 times 5.45 and then divided by cosine 48. So just do that in my calculator. And I end up with 177.56. Actually, they said around to the nearest tenth, right? So did they say that for our problem too? Yeah. So that would actually be 177.6, and our units are meters. So this is lateral area, so it's going to be meters squared. So 177.6 meters squared is our answer. There we go. Okay, so we know from the directions on the previous page that we want the surface area. So this is a pyramid, so the surface area of a pyramid is going to be 1/2 perimeter times the slant height plus, I'm going to do this in blue, the area of the base. Okay, so most of these numbers are going to be pretty easy to find, but some of them are a little bit more difficult. So 1/2, the perimeter, let's do that one first. Well, the perimeter is the perimeter of the base here. And so we have 3 sides. They tell us on the previous page it's a regular pyramid, so that means that all 3 of these sides along the base are the same. So the perimeter is simply 18 times 3, which is 54. So our perimeter is 54. Now what about our slant height? Okay, well, that's this distance right here. And so if you see, that kind of makes it does make a right triangle with a side of 9, a slant height, and a hypotenuse of 14 inches along here. So that means then that 9 squared plus our slant height squared equals 14 squared, which means that our slant height squared equals 14 squared minus 9 squared. 14 squared is 196. So 196 minus 9 squared, which is 81, is 115. And therefore L is the square root of 115. So now we're ready to plug that in. Okay, and I'll put that in red just so we can see where that number came from. And then we need to add the base area. Now this is going to be the trickiest part. Now the base area is an equilateral triangle. So what I'm going to do is I'm going to actually draw a triangle over here on the side. And we know that it's all 18, 18, and 18. So if I draw in the height of the triangle, I get that, and I see that this would, if I draw in the height, I'd cut it into a side of 9 and a side of 9. Well, since this is an equilateral triangle, we know that all these angles are 60. Well, if this is 60, I could even write that in here, 60, 60, and then to cut these two in half, that'd be 30 and 30, and then this would be 90. Well, that makes this a 30, 60, 90 triangle. So if this is 9, that's what this is supposed to be here, a 9, and then the hypotenuse is 18, that means the height here is 9 rad 3. We need that because in order to find the area of this triangle, you have to use the formula 1/2 base times height. That is the area of a triangle. So 1/2, this guy's base is 18, and its height is 9 rad 3. We could simplify this just a little bit, right? So 1/2 of 18 is 9, so you get 9 times 9 rad 3, and 9 times 9 is 81. So we get 81 rad 3 as the area of the base. So that's what I'm going to plug in here. 81 rad 3. Remember that capital B always means base area. So you got to find the area of the base. You got to know your area formulas as well. All right, from here now, I got everything plugged in. The next step here is really just to go to the calculator. So let's do the square root of 115. I'm just doing this in my calculator off on the side, and I'm going to times that by 54, and then also times that by 1/2, and that gives me this crazy number, 289, about 289.54, plus the area of the base we said was 8 rad 3, or 81, sorry, 81 rad 3, which is 140 point about 30. And if I add those two things together, I get about 429.84, and it was all in inches, so we're going to say inches squared. 429.84 inches squared. All right, there you go.